Hello and welcome to the NPTEL MOOCs course on Foundation for Virtual and Augmented Reality Systems. We are going to continue our discussion on VR navigation experience optimization. In other words, we are trying to understand in these lectures how to optimize the navigation experience in VR. So far we have discussed the idea of the psychophysiological or experience optimization in VR, where we emphasize that the objective is to primarily take care of the cyber sickness related issues, how we can take measures to avoid onset of cyber sickness or to minimize the possibility of cyber sickness. Now, in order to do that, we talked about one realistic natural walking model, and we have seen how this model can be utilized to formulate two approaches. One is optimal path approach, other one is optimal path under time constraint approach. In optimal path approach, we talked about identifying a path in this virtual world that lets the user explore all points of interest in minimum time. Now, the problem with this approach is that if the virtual world is large, such as Majuli River Island, this virtual tour, then there may be large number of points of interest, and to cover all the points of interest, to find out a path that covers all the points of interest in minimum time may not solve our issue, because that minimum time, minimum duration to cover, assuming natural walking speed, may still be very large as compared to the duration we expect to let the user exposed to in the virtual world, which can induce cyber sickness. So, essentially this optimal path solution may still lead to cyber sickness if the virtual world is very large. So, in such cases, and we are assuming that the user is exploring the world by walking, in such a case we can go for another approach, that is optimal path under a time constraint. So, there is a upper limit of time. So, the user will be exposed to the virtual tour at most for that time duration, which we are calling time threshold, and within that time duration user is expected to cover a path that will allow the user to cover maximum number of most important points of interest, where by the term covering I also mean that the user should be able to interact or inspect those along with navigation from one point to another. So, in order to do that, we introduced few more terms such as importance of a node, waiting time at a node, and then we had shown how to solve for this problem. So, these two we have discussed in the previous parts of the lecture. Now, in this lecture we will try to understand how this theory can be put into practice. Of course, we will not go into all the details of the theory, but the initial part, that is how a practical problem can be modeled in this graph theoretic form, so that these optimization approaches can be applied. That we will do in terms of the case study that we had introduced earlier. So, let us try to understand how we can use the idea in practice with respect to the Majuli case study. Just to recap, Majuli is the river island on Brahmaputra river, which is on the eastern part of the country in the state of Assam, and this is the river island, how it looks, surrounded on all the sides by rivers and its Brahmaputra river and its tributaries. It is also world's largest inhabited river island and a contender for UNESCO World Heritage Site. So, there are these satras or the monasteries of Vaishnavite faith, which contain several cultural aspects, tangible, both tangible and intangible, and there is a total of 22 satras. Each satra has several parts, including a Namghar, the prayer hall, which is the central part, then Monikut, place of idol, Hathis, hostel of the disciples, and residences of the Satradhikar or the master of the Satra. In that island, there is one Guwahati Satra, which is one of the largest, most prominent and most visited Satra on the island. Now, the campus of that Satra covers approximately 1200 square meter, a pretty large area, and we have estimated that there are at least 25 points of interest in that Satra, at least. Now, what we want is to make a system controlled VR tour to cover the Satra, to get the experience of that Satra. Here we are assuming that we will be having a walking based exploration, and in the walking based exploration, to have a realistic experience, we will be using the natural walking speed model that we had discussed earlier. Now, in a practical scenario, if somebody wants to explore the whole Satra by walking, it may take up to a day to explore the whole site, including stoppage at the points of interest. Clearly, the whole day exposure to a virtual world, if we are trying to do the same in the virtual tour, is not recommended for a VR tour, because that is surely going to induce cyber sickness. So, we should not do it. But then how we can come up with a path, optimum path that minimizes this duration, and if the minimum duration is still not at an acceptable level, still not below the time threshold, then how we can come up with a path that allows the user to explore in the virtual world most important POIs within the given time threshold. So, using either of the approaches, we can actually propose a path to maximize the user experience in the virtual exploration of the Satra. In order to do that, first we need to map the site to a graph. So, essentially we need to convert the Satra, the campus of the Satra with all its POIs into a graph, where the points of interest will be the nodes. So, as I said before, at least 25 points of interest are there. So, at least 25 nodes should be there. Also, we need to calculate the distance between them, the Euclidean distance, so that we can use it as the edge weights, edge that is connecting pair of nodes. Also, if we want to implement the second approach, assuming the first approach yields a minimum time which is still more than the time threshold, then we need to have some idea of the relative importance of each of the points of interest or each of the node. Along with that, in order to be able to find out an optimal path following the second approach, we also need to estimate the maximum wait time at each POI, which is required for a user to stop at the POI, inspect it, interact with it if possible, and then resume the navigation. So, there are several challenges, several things to figure out. First thing is converting the site to a graph representation. How do we do the mapping? Clearly, this is not an easy task to do, and it requires detailed field study and of course, patience, because it cannot be done in one shot. So, initially you can come up with a plan of converting it to a graph, then that graph may not look proper, you need to revise it. It is an iterative process, it requires patience. Now, in our case, what we did? A team visited the site, so one field trip was made during the Kati Bihu festival, which gives a better idea about the places of importance POIs, observation and interaction time or the waiting time at each POI. Any festival time could have been picked up, but due to several logistical issues, we had chosen one of those important festival times. Now, observed during that field visit, the team observed the people's travel behavior throughout the whole day, how the people travel within this satra, where they stop, what they do. It is kind of field study, or in other words you can say it is a kind of contextual inquiry, similar to a contextual inquiry. So, you can refer to earlier lectures on contextual inquiry to understand this concept. Now, the team also talked to local people, mostly campus residents, and the Satra committee members for further clarity on certain aspects of the observations. Now, the team members asked two questions to the people. What are typically the places people visit when they come to this place? And what are the places you, that means the person being interviewed, suggest a tourist must visit when they come to the Satra? Now, based on observations, manual recording of the behavior and interactions with the committee members or people who are resident of the campus, the team could accumulate the desired information in terms of the points of interest and then could formulate a graph. So, they could accumulate information on point of interest. Once the points of interests are known, then the distance between them can be measured, which they did, and then that could have, that can be used as weight between the nodes. Also, by talking to the people, some idea was gained about the relative importance of each node, and accordingly the importance was assigned to the nodes. And also based on the observation of people's behavior when they visit the places, an estimate of the maximum wait time was done at each POI. So, all these information were obtained through observations, manual recording and interactions with the people there. So, based on that analysis of data and the information, the campus can be modeled in this form, having the points of interest, having some locations, places, objects and the points of interest. So, as you can see here, the nodes in circle indicate the points of interest. Note that the points of interest need not always refer to the actual physical object, such as a lake is not considered a point of interest. However, the corners of the lake considered points of interest. So, starting from the entry point number 1, then the gate is another point of interest, then different paths, and along the paths different points of interest are marked. So, in this graph you can see the points of interest denoted by this field circles, whereas the artifacts places in the campus are shown in rectangular forms. So, this is what was obtained based on contextual inquiry or the field study, and once we know the points of interest and formulated a graph, say for example, between node 12 and 13, the distance was measured as 58 meters. So, this will serve as the weight between these nodes or weight for this edge. Similarly, everywhere the weight was obtained and also the relative importance was given plus wait time. So, that relative importance and wait time is not shown here. To keep things simple, only the graph form is shown along with the distance between the nodes. Now, once this is there, we can readily use our algorithms to either come up with an optimal path covering all the nodes, 25 nodes, which can be navigated, which can be traversed in minimum time, or we can come up with an optimal path which can be traversed within a time threshold, but during that period maximum number of most important POIs can be covered, taking into account the wait time at each POI. So, that can be done straightforward from here based on the algorithms and the available tools. So, this is how we can put the idea into practice. Thus, so once this graph is obtained, we can now apply the algorithms to get an optimal path using TSP solver, the whole path covering all the nodes, or an optimal path within the given time constraint set by us, that is the time threshold, using the VRPP solver. So, let us quickly summarize what we have done so far. So, we started our discussion on experience optimization in XR. Specifically, we are talking of VR experience optimization, where we are emphasizing that this is related to psychophysiological optimization. So, idea of optimization we talked about, then idea of psychophysiological optimization in VR experience we talked about, which was primarily aimed to take care of the cyber sickness issues, and there we talked about couple of approaches, optimal path under time constraint, and we have also seen how these approaches can be put into practice. So, we talked about two types of optimizations that are of importance to XR. One is psychophysiological or experience optimization, and other one is the resource optimization. So, in the next lecture, our focus will be on resource optimization for immersive experience. So, throughout the discussion we referred to many prior works. So, this is the list of references that can be made use of to get more idea on the different topics that are covered. So, 1, 2, 3, these 3 references are there. Along with that, there are 3 more references, 4, 5, 6. So, these total 6 references you can make use of to get more clarity on some of the topics that we have discussed here. So, I hope you could follow the overall flow of lecture, you could follow the concepts covered, topics discussed, and you enjoyed the discussion. So, looking forward to meet you again in the next lecture on resource optimization. So, till then, thank you, goodbye and happy learning.